Hey everyone, Mr. Skelton here back at it. We are starting Unit 3 today. This is going to be Lesson 1. This entire unit, for the most part, is going to be about quadratics and quadratic equations, quadratic functions, graphing quadratics, writing equations of quadratics, etc. So today we're going to kind of introduce to you quadratics, kind of explain to you the point of quadratic equations, why they are what they are, and what they look like. And just some basics. And then at the end we'll do something new, but in actuality, because we just got done with matrices, it won't be new because you've done it already. So you spent a whole unit in Algebra 1 on quadratics as well, so hopefully a lot of this stuff is familiar to you. So let's get into the why. Why quadratics? Well, let's just pretend we're modeling Andrew Luck's pass, quarterback for the Colts. Always hurt, but he is who he is. Okay? So here's Andrew Luck, here's his football, okay? So we're saying why quadratics? Well, if Andrew Luck, he's about 6'5", 6'4", when he releases the ball, if it was just a straight line, that would be y equals 7, right? That would be considered, you know, an equation of just a horizontal line. Let's say that's 7 feet. So, you know, he's 6'4", arm raised, ball's up, 7 feet. We all know that a pass doesn't work like that, right? There's gravity involved. Let's say that, okay, he throws the ball another time, okay, and it has some velocity or some speed. So this would be an example of something like, let's see, y equals 20 feet per second, something like that. So here's your linear equation, right? Here's where it's leaving his hands. His initial height is at 7 feet. That's where the ball's at 7 feet. And it's traveling at a rate of 20 feet per second or something like that. That's your linear equation. Well, that's obviously still not true, right? Because when he throws the ball, it's eventually going to come back down. That's where the quadratic comes into play. It may be traveling at this initial velocity, but it eventually is going to fall back down, okay, because of gravity. And this is why or how we get a quadratic equation, which would look something like this. I'll give you a very common example, and I'll use some of the numbers that I used. So this would be an example of the quadratic. This 7 is its initial height, the football's initial height, 7 feet. We talked about that here. Here's your linear aspect, your linear part to it, the 20 feet per second. And then this negative 16t squared, that's the actual quadratic part. That negative 16, if you remember from our beginning days and from your Algebra 1 days, the reason it's a negative number is because, remember, your parabola is opening upside down, right? So it's kind of neat. This is your constant, what we call the constant term. This is your linear, and this is your quadratic, okay? Now, to make something a quadratic, all you really need is this first part right here. That's what makes it a quadratic. But in a lot of the cases, the real world models, you will have a linear and a constant part, and you can see how that all kind of works together there. Okay, so that's a little background information on quadratics. So let's kind of get into standard form and talk about standard form. And I really actually already did this, but I'll just review again. Your c is considered the constant. That's always going to just be a number by itself. Okay, if there is one there, so like 7 or 2 or negative 5, it can also be a minus sign there. This is your linear term, all right? And if you cover up just the ax squared, this is just like y equals mx plus b. Instead of an m, it's a b, but that's y equals mx plus b right there. And so that's your linear. And then we just talked about this. This is your quadratic. Anything with x squared or variable squared is considered a quadratic. Those are your terms right there, okay? Standard form. So a couple questions on standard form. It says put the following functions in standard form, then determine if they are linear or they are quadratic functions. So we're just going to do some basic multiplication. You're going to FOIL. It's going to be 3x squared minus x minus 15x plus 5. That gives me 3x squared minus 16x plus 5. I know I'm working through that kind of fast, so when I simplify, that's what I get. Then that's x squared. That's going to be a quadratic. So that our answer is a quadratic function here. Now let's take a look at what we got here. I'm going to distribute this 3 through, so 3x squared plus 6x minus 9 minus the 3x squared. Since that's outside of the parentheses, it does not get distributed with the 3. My like terms are negative 3x squared and positive 3x squared, so those cancel out, and I'm left with 6x minus 9. What type of function is that? That is linear. That's your y equals mx plus b. Okay, so you'll have a couple questions like that on your homework, pretty basic stuff. Now, again, this should be review for you, but we're just going to talk generals here, in generality with quadratics and what the graphs look like. Well, we've already actually graphed some of these before. We've shifted them, if you recall from Unit 1. But the graph of a quadratic is called a parabola. That's what its name is, all right? And parabolas can open up or they can open down. So this is obviously a parabola that is opening down. What that means is its leading coefficient is negative. If it was positive, it would open up. There's two components here that we want to make you aware of as we get started. One is the axis of symmetry. And the axis of symmetry, parabolas are always symmetric, which means same on both sides. So I just kind of did this by hand here. But that dotted line will cut this parabola in half. If you folded this over, it would map exactly onto the other side. It's symmetric. It's same on both sides. Okay. I'll teach you how to find that, not in this lesson, but in a couple lessons. I'll teach you how to find this dotted line, the equation. It's a vertical line, so it's always going to be x equals a number. That's going to be your axis of symmetry. It will be like x equals 4 or x equals 5 in this case. It's just a dotted line. That's vertical. And then we can talk about the vertex, and we'll talk about how to find that and whether that vertex is a max or a min. So in this specific example right here, your vertex is always going to lie on your axis of symmetry. All right? Your vertex is always going to lie on your axis of symmetry. So in this case, if I asked you if this point is a max or a min, just use common sense. Is that the highest point or the lowest point of this parabola? That's at the highest point. That would be considered a maximum point. If I just did another quick example right here, and I had a parabola that opened up, okay, and I had my axis of symmetry right here, let's say, and what would that point be, a max or a min? That would be considered a min because it's the lowest point of the parabola. All right. Now the next slide is what is going to be new, quote unquote new for you, but we're going to use some technology. I got my graphing calculator here, so if you need to hit pause to grab yours, go ahead and do it, because I'm going to have you try this on your own. You can see the answers provided there for you, which is good, so you can set this up. So it says write a quadratic equation that passes through the following points. So what is taking place here? Well, they're basically saying to you that 2, 3, 313, and 429 are points that lie on a given parabola. They're somewhere on this parabola. I want you to come up with the equation for this parabola. Okay, now if you revert back, a lot of our equations are going to look like this. There's going to be three parts to it. There's going to be that constant. There's going to be that linear term, right? In this specific case, this was where the football started. This was his speed, and then this was gravity pulling it down. So we're going to have an A, B, and a C value. Okay? So if you come back here, this is standard form, A value, B value, C value. So when we get to this, kind of moving all over the place, your job is you need to find what the A value is, the B value is, and the C value is. That is your job. When you're writing a quadratic equation, y equals ax squared plus bx plus c, that's called standard form. You need to tell me what the A value, B value, and C value is. So how do we do that? Good question. Well, I'm going to call this xy, xy, and xy. And what I'm going to do is I'm going to generate three equations because I have 3 points, and I'm going to use standard form, and I'm going to plug in my x value and my y value into the standard form equation, and I'm going to create 3 equations, and you're going to probably figure out real quick how we're going to do this. So let's plug in 2, 3, so x equaling 2 and y equaling 3 into my standard form equation and come up with an equation. Let's plug in 2 for x. Well, what's 2 squared? 2 squared is 4, so I'm going to get 4a. Now, I just put the 4 in front because we always want to put the number in front of the variable. Okay? b times x, remember x is still 2, so that's going to give me plus 2b. And then my C value, I don't know what my C value is. I don't have an X with it, so I'm just going to put plus C. And that equals my Y value, which in this case is 3. Now you may be wondering why I didn't put the 3 in front. You're going to see here in a second why I'm doing this. All right, so let's move on to the second point, which is x equaling 3 and y equaling 13. We're going to plug 313 into this equation right here. So what's 3 squared? That's 9, so I'm going to have 9a. b times 3 would be 3b. I don't have any x value to plug in for c, and I don't know what c is, so it's just plus c. And what does that equal for my y value? My y value was 13. Okay? And then we got to do this one more time. Here's my third point. So plug in 4 for x. 4 squared is 16a, plus 4 times b would be 4b. Don't know what my c value is, and my y value is 29. Now, what does that look like to you? That looks like a system of equations with 3 unknowns, and so we need to solve this for a, b, and c. Now, you can use substitution, you can use elimination, you can go down that path, but what I'm going to do is use my graphing calculator, and I'm going to use matrices. Okay? Make your life way easier. So, from last unit, let's convert this into a matrix. 4, 2, 1, 9, 3, 1, 16, 4, and 1. That's going to be my coefficient matrix. I have A, B, and C. That'll be my variable matrix. And my constant matrix, or answer matrix, will be 3, 13, 29. Okay? Now, I'm going to call this matrix A. I'm going to call this matrix B. So I'm going to take out my calculator here. Second matrix, and I'm going to go over to edit, and I'm going to make this a 3 by 3, and I got 4, 2, 1, 9, 3, 1. Get that in the picture for you. Enter, and then I got 16, 4, and 1. So that's going to be my matrix A. I'm going to go back to second matrix, go over to edit, got to edit matrix B. This is going to be a 3 by 1, and that's going to be 3, 13, and 29. And remember, when I want to solve this with my graphing calculator, I have to go A inverse times B. So I'm going to go second matrix, there's A inverse times second matrix, go down to B, hit equals, and I have 3, negative 5, and 1. Now you need to know how to apply that answer. What does this mean? Well, what was your variable matrix? A, B, and C. So this is your A value, this is your B value, this is your C value. And so the answer you can see right here. Y equals, you take your A value, which is 3, x squared. What's your B value? It's a minus 5, minus 5x. Your C value, plus 1. Whoop, plus 1. And that's your answer. Using matrices, way easier. Now, will I ask you to solve this by hand? I could. You should be able to solve a 3 by 3 by hand using substitution or elimination. But for the sake of the notes and to keep things simple, let's use the graphing calculator and your knowledge of matrices. All right. Last one. I want you to hit pause. I want you to try this one on your own with a graphing calculator, and then I'll check back with you. Okay? All right. We're going to do the same thing we did before. You're writing this equation. Again, we're using standard form, what we call standard form of a quadratic equation, which is y equals ax squared plus c. Again, that's called standard form. You should know what that is. You should have that memorized by now. That's standard form. And we're going to plug in our x's and our y's and make 3 separate equations and into our y equals ax squared plus bx plus c. Okay, so let's do that real quick. My my x value is 1. 1 squared is 1. 1 times a is 1. So I'm going to have 1a. I'm going to have plus b. 1 times b plus c equals my y value is a 0. I'm going to plug 2 in for x. So 2 squared is 4a plus 2b, because 2 times b is 2b, plus c equals negative 3, because negative 3 is my y. Remember, I put my y's on this side here. And then my last point is x value is 3, so 3 squared is 9. 9 times a is 9a. 3 times b is 3b, plus c equals negative 10. And I want to make this into a matrix. 1, 1, 1, 4, 2, 1, 9, 3, and 1. That's my coefficient matrix. I'm going A, B, and C for my variable matrix. And my constant matrix would be 0, -3, and -10, or what sometimes I refer to as the answer matrix. So I'm going to call this matrix A, call this matrix B. In my calculator, I got to go A inverse times B to get my answer. So let's take out the calculator here, and let's plug these in. Second matrix. Again, you don't need to go to C and D. Just go over to edit. You want to edit this 3 by 3. Plug in the new numbers. 1, 1, 1, 4, 2, 1, 9, 3, 1. Second matrix. Edit matrix B, which is also a 3 by 1. And I have 0, -3, -10. Second matrix, matrix A, inverse, times second matrix B equals, and I get -2, 3, -1. And again, you have to know what those mean. That's your A value, B value, C value, and you rewrite your standard form equation with your A, B, and C value, and you get that. Okay? If you have any questions in class, be happy to help you out.